The chapter test opens today and it will close on Thursday. And then on Thursday, we'll be going over the big introduction to vectors. So we'll start the rest of chapter 7. We did the first part of chapter 7 when we did law of sines and law of cosines. Now we're going to do the rest of chapter 7, and then we'll finish up the semester with chapter 10. So the chapter 6 test is our third chapter test. We have one more, which will be the chapter 7 and 10 test. That's the last chapter test before the final exam, which will be in May, the very beginning of May. So we are this will be our third chapter test. There is a quiz that closes tonight. Let's go ahead and look at that. So last week in week 11, we have a quiz that's just on solving equations, solving these trig equations. So that's going to close tonight. You need to get that done. The homework is going to be due on Friday. I think that shows up Friday. So finish up your chapter 6 homework on Friday night. Then coming over, the chapter 6 test is there. It opened up today. It does require lockdown browser, and it's just on your trig identities and on solving trig equations. And if you look back up in modules, there are several cheat sheets that I would, if I were you, I would print off. I would make sure I had my trig table and my calculator. I would make sure that I had the identity sheets. There was this one. This one said it's just called identities page. And it doesn't have all of them, but it does have some of the ones like your Pythagorean identity, your even odd identities, the power reducing formula. The reciprocal identities are helpful, your quotient identities, and it also has the double angle identities that you'll be using. And it has over here the sum and distance formulas. Now, the thing I don't like is when they do this plus or minus business, because it assumes if this is a plus, what is that supposed to be? So whenever they do this plus or minus, I would prefer to look at another chart. So that other chart that you would look at is also listed up there, further on up in your modules. And this is the one in PDF form. And again, it has a lot of good stuff. So it has some of the same stuff, but it has, now see, it does the dang plus or minus also. What you may want to do is the plus or minus business. If you look at our lectures, it doesn't have the plus or minus, but I think it's opposites. I don't ever go through and memorize these, but I think if this is a plus, this is a subtract. If this is a subtract, then this is a plus, but we would need to verify that with the lectures. The lectures don't have the plus or minus business. This alternate form of the half angle is your lowering the power or power reducing identity. There's your product to sum, your sum to product. By the way, this one was sum and difference. Sum and difference. So your sum, it still has the plus and minus there. Okay, so we have these different ones here, the double angles. It even has the radian to degrees and degrees to radians, and though we don't need that for this test, it's good to have. And the unit circle, we don't really probably need that for this test, but it's there. don't know that any of these are applicable. So really what you need for this test are your trig tables. And I would have this formula identity page, and I would have the other formula in identities page that's called identities page. And I would make sure I had those. Okay, so any questions about what you're going to need to do to take the test? Anybody? Okay. So let's go ahead and get started on the review part. So up on for week 12, I have listed the review and the solution. So, and then I actually have a few videos that are specific to that particular problem. This was I made back last spring, because at this point is when we flipped over into, I was teaching this class and we flipped. We had just concluded chapter 6, but we had not done the review yet when we came back from spring break, but we were in online mode. So that was fun. That was a trip. Changing a class that's seated, flipping it into online at a moment's notice. That was fun, along with all my other classes. But anyway, so use the reciprocal identities to rewrite the secant. And so if I were to look at them, we would see, let's see, that coming down here, that the secant is 1 over the cosine. Use the Pythagorean identity to write as a cosine in terms of cosine. 1 subtract sine squared 4x. So, well, I'll switch to this one. So we take our Pythagorean identity, which is sine squared theta plus cosine squared theta equals 1, and we subtract the sine squared over to the right side. Now this says that you can replace 1 minus sine squared some angle with cosine squared same angle. So I'm going to replace 1 minus sine squared 4x with cosine squared same angle 4x. So the Pythagorean identity never changes the angle, unlike the double angle, which changes the angle. Pythagorean identity keeps the angle the same. Okay, so the next problem is use the double angle to write as a cosine. Now notice this is almost the same as the previous problem, but the previous problem didn't have a 2 in the front. The Pythagorean identity didn't allow the 2, a multiplier of 2 right there. So this is a double angle. So when I go look at the double angle, these are all your double angles. The cosine of twice the angle can replace 1 minus 2 sine of an angle. So I can replace this with a cosine, not a cosine squared, but a cosine, but I have to double the angle. So I'm going to say, to double it, I say times 2. So 2 times the angle will be 2 times 4x, which would end up being the cosine of 8x. So I'm going to choose the multiple choice answer of the cosine of 8x. Now I've noticed we've got a few more people here. I see Luke is here. I think that's all. That's it. Okay, so now let's go to the next problem. Use the Pythagorean identity to write as cotangent. Now, I'm going to pick the identity. that involves the cosecant and the cotangent. They're different from the sine and the cosine. So I want to go to my identity and I want to pick the right one. So notice it says here that 1 plus the cotangent squared of an angle is equal to the cosecant squared of the same angle. So 1 plus this, 1 plus the cotangent squared equals the cosecant squared. So now I may have to manipulate this equation. In other words, I may need to move the 1 to the right side with the cosecant squared. And to do that, I would subtract. So let's see how it's presented, because I don't really remember whether they gave it to us just this or whether they said this minus 1. But this is the set relationship spelled out in our identity. All right, so notice it does have a subtract 1. So we've got cosecant squared subtract 1. So I've got just cosecant squared here. If I subtract the 1 to this side, then I will have my cosecant squared subtract 1, which is would just be equal to cotangent squared, same angle with the Pythagorean identity. Okay, so this would be equal to the cotangent squared. Notice that the angle is the same with the Pythagorean identity. So be careful with the angles. Pythagorean identity, the angle stays the same. Okay, any questions on that one? Now, is this stuff you worked with before? I know that some of the stuff, like solving trig equations where you had to factor them, most of you said you didn't have that, but you did have it, the simple one. And a lot of this stuff you said that y'all have had before. Have you've worked with the Pythagorean identities? Have y'all done that? Having to manipulate it? I know that you usually, a lot of times, will work with sine and cosine, but not always cotangent and cosecant. We do work a lot with tangent and secant in Cal 2 and sine and cosine. A little bit of the second one, but not as much. What do you think? Looks like we've got somebody else that's shown up. Y'all, when y'all come, you need to, there's nothing wrong. Just send me a little note that says you're here. I see Garrett's listed twice. Okay, that's where it is. All right, now to number 5. Evaluate the inverse secant of this value on the interval from 0 to 2 pi. So from 0 to 2 pi, that's the first quadrant only. So I'm going to go to my trig table and I'm going to look to see when is the secant equal to this value, and then the answer is the angle. So when they say inverse trig function, they mean tell me the angle that produces this trig value. So if I were to look at the trig table, I'm only going to look in quadrant 1 because they restricted the interval. So I'm going to look only on the row for secant, and I'm going to look for that value, and then I'm going to specify the angle, and it would be pi over 6. Okay. So even though there are other possibilities, we're going to go strictly by the interval that they say. By the way, I do want to bring this up, that bracket means that if the answer had been 0, I could say the answer was 0 if the answer had been 0. But if the answer had been pi over 2, but they have a parenthesis around pi over 2, that means go up to but don't include the endpoint, and I wouldn't say pi over 2 because it had a parenthesis. Now, I know that those were not, the endpoints were not the answers, but I'm just saying, had they been the answer, I've had students say, but why would I not have put pi over 2 if that was an answer? And the parentheses would say, no, don't include the endpoint. All right, so state all the solutions. Now, this was the degree 1 trig equation that I'm first going to try to isolate because it's not a secant squared. It's just a single trig function, and it's a degree 1, no exponent. I'm going to isolate my secant first. So there's an order. I want to undo the adding or subtracting before I undo multiplying or dividing. So I'm going to add the 6 to the right side and then divide by 3. And that will isolate my secant for me. And it'll end up being a positive 6 divided by 3, which would be a 2. So now I know that the secant, I'm looking for the angle that produces a secant value of 2. Now this again says I could, if the answer was 0, I could specify 0 all the way up to 2 pi, but it says a parentheses means do not include the 2 pi. But it doesn't turn out that either one of those are the answers, so it's kind of a moot point, but it's always good to make sure everybody knows how to read that. So I'm looking for 2 all the way across, and I find a positive 2 when the angle's pi over 3, and a positive 2 when the angle's 5 pi over 3. So I'm going to choose the 2 answers, pi over 3 and 5 pi over 3. Now the next one says use sum to product to rewrite the cosine, the subtraction of 2 cosines that have different angles, to write them as a product. So they are technically, we think of subtraction as a sum of the opposite value. So sum to product means to multiply. So we're going to have them where they multiply together. So we're going to go to sum to product. I'm just going to, let's see, I'm looking for sum to product. Did it show up on this identity page? Nope, I don't see it on this page. So I'm going to go to the other one. Now I have it on the form, but it's always good to know where they are on these forms. So sum to product is right here. So I have to choose the one that matches the problem I have. The alpha and the beta indicate the angles were different. And I'm looking for either a sine plus sine, sine minus sine, cosine plus cosine, or cosine minus cosine. Ours was cosine subtract cosine. So we're going to use this rule here. Notice that the answer says put a -2 and then say times the sine, and I come up with this angle, times the sine, and I come up with this angle. So I'm looking for an answer choice. First of all, I need to make sure I pick the one that has a sine times a sine, but I also have to make sure the angles are correct, and I have to make sure the multiplier in front is correct. Okay, so let's go. And so I'm going to go do, now the first thing it says to do is take your 2 angles and add them together and divide by 2. So the thing that I will do, I'll take my 4y plus my 6y, and I'll add them together and get 10y, and I divide by 2, which gives me 5y. Now it says subtract them. So this will be 4y subtract 6y which gives me a negative 2y. Then I divide that by 2, and I get a negative y. Well, now I've got to pull in another identity because we're not going to leave a negative angle because that can be cleaned up. The even-odd identity says if I have a sign of a negative angle, I can change the angle to be positive, but I will have to multiply the front by a negative 1. So this negative 2 will need to get multiplied by a negative 1, which will make it be a positive 2. So the correct answer would be 2 times the sine of 5y times the sine of y. And looking at my answer choices, I had 2 that had sine and sine. And if you're not careful, I would choose B because it's almost correct. The problem is that because of the even odd identity, we have to multiply that by negative 1 to get a positive 2. All right, now going to product to sum. Use product to sum to rewrite two cosines multiplied together as the sum. Now, when it says sum, it could be subtraction also. So notice all of these are the cosines that are either added or subtracted. They all have a 1/2 in the front, but the signs are different. These are both positive. This is a minus and a positive, a minus and a minus, and a positive and a minus. So I'm going to have to figure out, first of all, the right formula to use. So I go to product to sum, and I look for two cosines multiplied together. So on this one, don't have what I need. So I go to the other one, which was in PDF form, and I'm looking for the product to sum that has the two cosines multiplied together. So it says I'm going to take the two angles in order, and I first am going to subtract them. And then on the second one, I'm going to add them, and then I'll have a plus sign in the middle. Okay, so it says we're going to take, for the first one, we're going to subtract them. So 4y subtract 6y is a negative 2y. Now, the problem with cosine, it's different than the sine. The even-odd identity says that when to rewrite with a cosine, to rewrite it as a positive angle, I just rewrite it as a positive angle, and I don't do anything. I don't multiply by negative 1. I don't do anything different. That the cosine of a negative angle is the same as, or has the same value as the cosine of a positive angle. So I can just replace this with a positive angle and not change anything in the front. Now the formula says to add them together and then add the two angles together to get 10y. So I'm looking for 1/2. I'm looking for both of the cosines to be positive. So the answer would be A. Going to number 9. Solve the equation for y. Now, if you're not careful, you will think that I have to do something to find the angle. But when they say solve for y, they want you to just isolate the y. So I'm going to focus in on the right-hand side here, and I'm just going to undo the stuff that's involved with the y. So I'm going to subtract a 1, and then I'm going to divide by 6, and that will solve for y. So solving for y just means isolate your y. Any questions on that one? We didn't do one like that in class, but in reality, it's really like what we have done all along. This just had a cosine there. Now the other way is when it says solve for theta. This time theta, it means I'm going to get theta by itself. So it means I'm going to solve for the angle. So the first thing I'm going to do is notice that the only thing that separates theta from being isolated is that it is it's the angle of the cosine. It's not a multiplied. So what I need to do is undo cosine. The only way you undo a trig function is with its inverse trig function. So I went ahead and wrote the cosine on the left side and the 6 plus 1 on the right side. Now I'm going to take the inverse cosine of the entire left side and of the entire right side. That cancels out the cosine, and now theta has been isolated. It is the inverse cosine of 6y plus 1. Now, it didn't ask me to solve it or anything like that. It just asked me to isolate it. By saying solve, it means isolate. Now, here we go. Another trig function, a trig equation. It says state all the solutions on the interval from 0 to 2 pi for this equation. So the first thing you want to do is I want to think about how many trig functions do I see, and are any of the trig functions raised to a power like secant squared? Because if it's just one trig function with no exponent, it says not exponent, no exponent. This is our basic kind. To solve the basic kind, all we do is first isolate the secant. So I'm going to add the 2 root 3 to the right side, then I'm going to divide by 3. So the first step is to isolate your secant. So I add this, and then I divide both sides by 3. Now, to solve it, I'm looking for the angle that produced this value on the chart. So you can do it this way by saying the inverse cosine of both sides and saying x is that, or I could just know that it said to look from 0 to pi and look for that value on the secant row. So we see it at pi over 6, and we see it at 11 pi over 6. And so the answer would be, why does this not show the answers here? Am I on the wrong one? No, this is the answer. So we see the answer is pi over 6 and 11 pi over 6. I just didn't indicate what the correct answer was. That's weird. I didn't know. Anyway, so the answer would be C. Questions on that one? All right. Now, I only see one trig function, and yet this is the more complicated kind, because notice that the one trig function has an exponent of 2. So the way we solve this is by factoring. So this is the difference of squares. And so what I'm going to do is I'm going to factor that, and cosecant times cosecant is cosecant squared, and then a plus 4 and a minus 2 multiply to give me the negative 4. Now I set each parentheses equal to 0, and now I've got two basic trig functions or equations. I'm going to isolate my cosecant by subtracting 2 to the right, and on this side I will add 2 to the right. So the answer and I think it's set on a certain interval from 0 to 2 pi, I'm going to go look and see all of the places, all of the times that the cosecant produced either a 2 or a negative 2. So I have pi over 6 and 5 pi over 6, and I have 7 pi over 6 and 11 pi over 6. So these four answers are all the angles that produce that are make this a true statement. So the answer would be D. State all the solutions for this equation on, now this time it just says 0 to pi, so that's just quadrant 1 and 2. Notice I've got two trig functions, one is squared, one is not. I'm going to need to factor this. So it's in quadratic form, 3 terms, no greatest common factor. I'm going to reverse FOIL. So I think what times what is secant squared? Secant and secant. Now I'm going to multiply and get 2, but I have to add and get a negative 3. So that would be a negative 1 times the negative 2 is a positive 2, but they add and give me a negative 3. So these are the two equations that I need to solve. Set them both equal to 0. Isolate my secant. And now I can either do the inverse secant of both sides, or I can just go to the trig table and look to see when do I get a value of 1 and when do I get a value of 2. But I'm only looking at quadrant 1 and 2 based on the instructions. And so that would be the angle 0 and the angle pi over 3. So going back, it would be the angle 0 and pi over 3. Now, if they asked you to do a generic answer, we would say 0 plus 2k pi because the standard period of secant is 2 pi. And then we would say, and then that ends up being just 2k pi. And then the other solution would be pi over 3 plus 2k pi. So that would be your generic form of the answer. Did I do the generic on the others? I'm sorry, I skipped over all that. Well, this one, I did on this one. Because the cosecant has a standard period of, no, I didn't do it on that, but the cosecant has a standard period of 2 pi, so it'd be plus 2k pi. All right, so now let's go to the addition. Use the addition formula, which is also called the sum formula, and angles 135 and 30 to evaluate the tangent. So in other words, what they're saying is use these two angles that are standard angles that sum together to give me this particular non-standard angle. So I can find the exact value by using these two angles. Now, this is one where you have to be careful because sometimes people work backwards from the answer, and there may be another answer that has the same numerical value as this, but it would be using other angles, and so it would be in a different form. So by saying use these angles to add and get this means there's only going to be one of them that is the right numerical answer for this value and the right form. So let's go through this plus or minus business. So this was in our lecture. Notice for the sign, see, this is why I don't like this. You have to know this. With the signs, the SIN, if it's add here, it's add there. If it's subtract here, it's subtract there. So you may want to write this down, this on your formula sheet. Now for the cosine, it's reversed. If it's add here, it's subtract there. And if it's subtract there, it's add here. You know, that's probably why they have, look at the, I thought it was weird the way this one did the plus or minus, and then they put the minus on the top. I think what they're saying is read it this way. On the top, if this is a plus, then it's a plus. If the bottom, it's a minus, is on the bottom, then it's a minus. Now notice with the cosine, plus on the top, minus on the top, minus on the bottom, plus on the bottom. So that's showing that it reverses. The same thing with the tangent. If on the top you read it a plus, well, this would be a plus and that'd be a minus. So plus, plus, minus. Or if it's subtraction, then it's subtraction up here, but addition down there. So, hey, actually, that's not bad if you know the little trick. Let me double check to see if they're like that on ours. Oh, it is like that. I never noticed that. That's plus and minus on the bottoms, and then they flip it, and then you read, if this is a plus, then it's a plus and then a minus. Oh, cool. I cannot believe I've never noticed that before. Well, I can learn something new every day. All right, so we are going to use the formula with the plus here because we're adding the two angles together like this to be the same as that. So it says that if you're adding, you're gonna add here, but you're gonna subtract there. So this would be the tan of this standard angle plus the tangent of this standard angle, then one subtract the tangent of the two standard angles together. So I have to go to my table and I have to see what is the tangent at 135, and it's a -1. What is the tangent at 30? It's √3/3. So I put that there. Then I say 1 subtract, and then this is a -1 times this. So now I've got to do the multiplication, order of operation going on here. You got to multiply before you can subtract. So this becomes 1 plus √3/3. And then this is a -1 plus √3/3. Now I distribute a 3, I'm multiplying by 1 in the form of 3/3. If I just multiply each term by 3, it'll get rid of the fractions, and this will become a -3 plus √3, and then this will be 3 plus √3. So I'm looking for this answer. Now notice you can reverse the order of subtraction. I can rewrite that as √3 subtract 3. So this is a little bit tricky because the answers all look about the same. So you have to be careful, but this is the correct answer. Any questions on that one? That one's a little bit tricky. In other words, when you're taking the test and you're working a problem like that, you kind of don't need to be doing about 3 different things at the same time. Focus on what you're doing, take it slow. All right, now state all the solutions to this tangent equation on all 4 quadrants. That's the interval there. So I want to isolate my tangent. It's just a basic tangent. There's no exponent on the trig function. So I'm going to add the 6 and then divide by 6, which will end up being tangent of x equals 1. So I undo the subtraction, then I undo the multiplication. And now I'm going to look, when is the tangent equal to 1? And it's at pi/4 and 5 pi/4. Now, you can take the time to do the inverse tan and solve it for x, or you can just from this point look for 1 on your tangent row, and the answer is the angle. Okay, use the quotient identity to help you simplify a cotangent times a cosine times a tangent. So the quotient identity we said was cosine over sine. Tangent is sine over cosine. Now we're going to use the same angle that they give us. So our angle is 2x. And these quotient identities, they do not change the angle. They stay the same. So this will be the cosine over the sine with the same angle 2x. The cosine just stays cosine, and the tangent becomes sine over cosine. Now, the tangent and the cotangent cancel each other out to 1, and you're left with just the cosine of 2x. So the answer was just the cosine of 2x. Lowering the power. Now, let's talk about this formula because it's called different things in different books. In some books, it's called lowering the power identity or lowering our formula. So we saw on this one here that was a PDF, it was the power reducing identity. It was right there, your power reducing identity. And then to make it fun, our textbook does something a little different. They call it an alternate form of the half angle identity. And there it is there. All of these are the same. So you just need to know how to get one of them. So it says to rewrite this without an exponent. So we're lowering the power, but it doubles the angle when you use this identity. So I'm looking for the cosine squared is equal to, now let's look at what it's saying here. Our angle for the cosine is 6x. So it's 6x right here. So what is it going to do to the 6x? Our x is 6x. Is our answer going to double the angle, or is it going to divide your angle in 2? Well, it's 6x here. When it's over here, it says it's going to be double what it currently is. So it's going to be 2 times 6x, which is 12x. So our answer should be 1 plus the cosine of 12x divided by 2. So coming over here, we can replace this by saying 1 plus the cosine of 2 times the angle, which is 12x. Or that dividing by 2 can be written in front as a 1/2. So either one of these are equivalent statements. And notice they put the 1/2 in the front on this one. Be careful because in your answer choices, you'll often see the angle doubled or the angle left the same or the angle cut in half. And if you use the wrong one and you use the one for the sine, it would have a subtract sign there. And so you got to be careful that you choose the right one for the cosine squared. Use the even odd identity to rewrite and simplify. So I don't want to have a negative angle. So any place I have a negative angle, I'm going to change to a positive angle. But the question is, do I leave it, the number in front the same, or do I multiply by a -1? It depends upon which one you're talking about. So this one is a tangent. So the tangent is an odd function. So to rewrite it, I'm going to have to multiply the front by a -1. So the 5 should become a -5. But that's not one of my answer choices. And that's because when I put the angles the same, now I've got like angles, like tangents, like terms. So a -5 tangent of 6y plus 2 tangent of 6y will add together to be a -3 tangent of 6y. So the correct answer is B, -3 tangent of 6y. Okay, we're on number 19. Use the double angle to simplify 2 sine 10x times cosine 10x. The double angle is either going to double the angle or it's going to half the angle, depending upon the direction you go. And when you say direction that I go, let's look at, I'll go to this one. The double angle depends. If you're starting on the left and you replace it with the one on the right, it cuts the angle in half. But if I'm on the right and I replace it with what's on the left, it doubles it. So it depends which way you read it. Well, we are starting with this. So we're going to replace it with a single sign, but we take our angle and we have to say times 2. Okay, so it says replace the 10x and the 10x with 2 times the 10x. And so our answer is going to be the sine of 20x. Any questions on that one? Okay, well, I hope you guys do really well on this test. Oh my gosh, it just seems to keep going and going and going and going and going. Okay, using different identities. Now, this is where it's kind of hard. Show that the cosine squared 6x is equivalent to all of the following except one. So we know that was the problem with the identities. When they don't tell you which identity to use, you're kind of like, okay, oh my gosh, like, I don't know. So let's just start. Is when I have a cosine, a 6x, and it's a cosine squared, and I equate it to the double to a negative angle 6x. Does the, and I don't change the front, is that true with the even odd identity that with the cosine, you just replace the angle with a positive and you don't change the front? Is that true? Yep, it is. The cosine, the even odd identity says just replace it. So even if it's a cosine squared, it just means that I do it for both. The cosines to multiply together, it still works for the cosine squared. So A is true. So it's not, the answer is not A. Now going, I've got this in red, so obviously the answer is B. Let's go to C first. The reciprocal identity says that cosine is equal to what? 1 over secant. Well, if this is squared, the secant has to be squared, and the angles have to be the same with your reciprocal identities. Now, the Pythagorean identity says that cosine squared is equal to 1 minus sine squared as long as the angle is the same, and it is. Now, coming down to D, this looks like the lowering the power reducing identity, because it was a square and now it's not. But when you lower the power, it doubles the angle, and notice it is doubled and it has the plus. And this is the same thing as D. D and F are the same thing. They're just rewritten with the 1/2 in the front. So B is the answer, but let's look at why this isn't so. So the double angle, probably, let's look at it. That looked like a double. The more you work with them, the more you recognize what identity it is. The double angle says that if I had a cosine with a double angle, I can replace it with 1 minus 2 cosine squared with this angle. So it's right here. But notice that the cosine is not squared. So a cosine squared would be equal to 1 minus 2 sine squared with the angle cut in half. So looking at this, we didn't have just a cosine, we had a square. So B is not the same. This is not equivalent unless this had been just a cosine. So the wrong answer, the right answer, which is the wrong identity, was B. Now here's another one. If I had 2 sine of 68, cosine of 68, which one is equivalent? Well, this is actually, to me, harder when you're using numbers as opposed to formulas. This is the double angle identity that says that I can say 2 sine of the angle cosine same angle is equal to the sine of double the angle. That 136 is double 68, so B is the correct answer. Secant squared is equivalent to which of the following? Well, when you're talking about a square, you're talking about the Pythagorean identity because the angles stayed the same on both sides. So a secant squared is equal to a tangent squared plus 1 with the angle being the same. So the correct answer is C. Sine squared 3 is equivalent to which of the following? The lower in the power identity says I can lower the power, but I have to double the angle. So we did double the angle and it has the subtraction. So this is the correct one. Notice this isn't correct because it has the plus sign. This isn't correct because it didn't change the angle. It didn't double the angle. So there is a bunch of questions. It kind of just goes all over everything that we've studied. So what questions do you have before you go to take this chapter test? Anybody? Because when you go to the higher maths, we do use these identities. Not all the time, but it shows up over and over again. One time you have to use one this day, maybe on another day, on the next week you use one. We do use them. We don't use them all the time, but we do use them. We use them to make our life easier. I know it feels like chapter 6 is to make your life harder, but we use it to make our life easier in the upper classes. So anybody have questions? You're all set? Nobody has a problem? Everybody's straight? You're working the homework? Nobody's had questions about the homework or anything like that? It's all good? Is it all good? Sort of good? Yeah. Okay. Well, Lindsay said it's all good. So then it's all good. What's the problem? Let me see. I've got a question here. Let's get it down. It doesn't scroll. Okay, well, Brandon, wonderful. Well, awesome. So make sure you take that quiz if you, well, no, that you've already taken, there's a quiz due this afternoon, right?
Yes, due tonight.
Due tonight. Make sure you take the quiz. And don't forget, through Thursday night, you have an opportunity to take that test. Well, I hope y'all do real well. Thank you for coming. And I'll see y'all on Thursday.